Even Meta is also the Meta CEO is also said, right? So they're planning to eliminate
Yeah,
level level
most of
four.
the coding job. Yeah,
level-
level four jobs. And
Yeah.
then Google has also said that uh, there will be, I mean, 50% of coding in this entire year has done by large language models. I mean, no coders are writing code nowadays. They are most of them were using the large language models. They have also released a statement saying that 50% of work is done by LLMs. So yeah, with that being said, I want to once again repeat this for the video purpose. The big AI world has one breaking news. The breaking news is that Alibaba is one company that has released a model which performed best than DeepSeek V1 and then GPT-4o. So these two are the models that GPT and DeepSeek has developed. Alibaba has claimed that their model is better than DeepSeek V1 and GPT. If you want to, I mean, go into deep, I have provided you links as well. I highly recommend you to go to their links and then check why it is performing well on all the benchmarks. Uh, Guys, can you please be on mute? So yeah, with that being said, let's dive into today's concept. In today's class, we'll continue our discussion on lists, and then we'll talk about tuples. We'll talk about few other data structures like set and dictionary. If time permits, I'll also discuss all those stuff. So yeah, so in yesterday's class, I taught you. I mean, I have discussed you all this stuff, basic stuff, and then I have also covered few control statements, and then I have started data structures. In that data structures, we had a discussion on list actually. So before I jump into today's class, I just want to ask you, uh, does everyone installed Anaconda in your systems? Is it done, or is anyone is facing difficulty while installing Anaconda?
Is Windsurf okay?
Anything, I mean, Windsurf, or if you guys have you installed Anaconda or not? I just want to know what is the status of the installation part.
So we installed Windsurf. It was easy to install.
Okay. Okay. Anyone?
The
Okay.
second,
I
yeah,
have
I'm not,
Visual Studio Code
Mm-hmm.
and Python. Is that
Okay.
okay?
Okay, it is also okay.
I have not installed it, but is Windsurf, if you install, does it come with a Python package as well, or do you have to install Anaconda separately or Python interpreter separately?
I highly recommend you to install Anaconda. Let's forget about this windsurf as it is creating a bit confusion in all of you guys. We can take this windsurf in the middle of the course, and then we can install all this stuff. But for now, what you can all do is first install the Anaconda in your system. That would be easy thing. So after installing Anaconda, what you'll able to see is you'll be able to see you'll be able to see Anaconda stuff. So yeah, you can 1 minute, guys. Yeah. So you'll see a navigator like this. So I highly recommend you to install. For now, let's be on the same page. So everyone will install Anaconda tonight. If not, if you are having Anaconda, what you can do is you can launch a Jupyter notebook thing. This is a thing where we all can write code actually. Okay, from today we'll write code here. In the middle of the course, I'll all help you in installing Windsurf. Okay, this would be an easy thing for
So,
all of us. Mhm.
Shekhar, one question.
Mhm.
We like yesterday, I think I mentioned that one. So Anaconda, we don't need to install. We can still use what is that, the cloud version, right? It's
Yeah,
easy.
you can. Yeah, you can if you want. Yeah, that is easy thing. If you see, we just need an IDE to code, right? So you can use cloud version, or if you want, you can download this and then download it into your local machine, and then you
Uh,
can. Mhm,
yeah, that's fine. But one question I have still, Vince, I just want to confirm:
mhm.
is that cloud version use the same features like the uh,
Yeah.
downloaded version, or is there
Yes,
any?
it is. Everything is same. If you want any packages, you can install there itself. You can install Quanda. Install is a command. You can install all the packages if the cloud version is not having. We don't find much different. Uh, yeah, for basic classes, anything is fine. But whenever we are going into a middle, we might need an IDE. At that moment of time, I'll ask you to install a Windsurf.
Okay.
Okay. So with that being said, what I want you guys is to install Anaconda, and then after installing Anaconda, you'll see a toggle button like this. Uh, I mean, if you click on that icon, Anaconda navigator icon, you'll land into this space. In this space, what you need to do is you need to uh, launch the Jupyter notebook. So once after launching notebook, there will, I mean, you'll be redirected to a Google Chrome, where this is an environment where you can create this stuff actually. Here, what you can do is you can create a new notebook. Here we have something called new. You can create a new, and then you can select kernel. You can select a default kernel, and then here you can write the code actually. So you can write code like this. Okay, this is how you can use Anaconda to write and to create new notebooks. Hope this is clear. So if you have any queries regarding this, you can ask me now. If not, we will continue our class. So is everyone is clear with this installation part, Anaconda installation part? Anaconda installation is very easy. Go to, I have given you the link from where you can download the Anaconda. Click on next, 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 next. The Anaconda will be downloaded. And then you can go to this navigator and then install the Jupyter notebook actually. So this is how uh, you can launch the Jupyter notebook. And from there what you can do is that you can code, and then whatever I'm saying I'll code. I'm from today I'll use this Anaconda so that we will be on the same page. Our entire class will be on the same page. After a few days we will install the Windsurf. So with that being said, in yesterday's class, as I said, we have started list. List is an ordered collection of elements, and one more important feature that we have discussed with respect to list is mutable in nature. So as this is mutable, mutability is nothing but we can add, we can delete, we can change that data structure actually. So you can add the elements to the list, you can delete the elements to the list, and then we have also, I have discussed you with a few methods like insert, append, remove, pop, and all the methods actually. So let's continue our discussion. So today now we are going to talk about list comprehension. So in list comprehension, let's say I have a scenario. My scenario is I want to create a list. In this list, I want to store the Venkat. Can you be on mute? Yeah.
Oh, I'm sorry. I'm sorry.
Okay. So uh, list comprehension, what we are doing is what I want to do is I want to create a list with the square of the numbers actually. Let's say if my n is 10, I want to in that list I want to store this square until my n. So I want to have 0 square, 1 square, 2 square, 3 square, and so on, n square. So this is my requirement. if that is my requirement, how can I do that is, let's say if you are using plain Python, I can declare an empty list. I'll use range function. Yesterday we had discussion on range function. So range function will start from 0 to n minus 1. So what this for loop will do is, now what I'm doing with this for loop is I'm iterating from I'm iterating from 0, I'll go till 9, and then whenever I am iterating, what I'll do is I will add the square to the list. I'll append the element to the list. So this is how we generally do if I want to create a list with a square of the numbers. So this is, I mean, the syntax looks bit heavy, right? So with the list comprehension, we can write that in one statement actually. So this is how we can write using list comprehension. So what I am doing here is I'm just cut downing all the initialization appending statements. See here for x in range. So let's say whatever the range function, whatever the range that we are having, what I am doing is here I'm having my condition. So here I'm performing my operation. So my operation is, let's say if x I mean initially the x would be 0, 0 square would be 0. So I will add that to list. So here we would be having brackets. So what I am doing is I'm adding elements to the list actually. So without this crazy uh, complex syntax with list comprehension, what we can do is we can shorten this stuff actually. So without all this for loop, initialization, adding, we can simply write this statement and it performs same actually. So if I run this, so you'll get the same output, but
You don't
the
have a
difference
print,
is,
right? Do you need to mention the print list or you don't need at all?
for the second thing.
Yeah.
Yeah, we can initialize it to either, you can initialize it to list and then we can print that.
Okay. That's what I mentioned. Thank you.
Actually, I didn't understand. What is this append x star 2?
Okay. What we are doing is, so just give me a moment. I'll share my screen and hope you guys are seeing my tab version, right? Yes or no?
Yeah, we
Yeah.
see black screen. Yeah.
Okay, sure. So here, let's say I want to create a list. Here in list, what I want to add is I want to add the square of the numbers. Let's say if my n is 4, I want to add 0 square, 1 square, 2 square, 3 square, uh, and 4 square. Let's say I want to add 4 square actually, 4 square as well. So what I can do, uh, I initially I'll create a list. So this is my list actually. This is my empty list. I'll name it as L. Now what I want to do, let's say if I want to add any element to the list, I am having two functions, right? So what are the two functions that are used for inserting the elements? One is append function and second one is insert function, right? So I can use either of the functions, and by using this, what I can do, I can add the elements to the list. So now here what I am doing is I am using append function and then I am adding the elements to the list. So what I need to do, let's say if my loop starts from, if for I in range of 5, what is my initial value? Initial value would be 0, right? I value would be 0. Now what I am doing is I'll append. So what L dot append will do, whatever the element that we are having, whatever the element that I'm having, I will add that element to L. L is the list that I have created. Here what I'll do is I'll do this square. So we have an operator. If you have double star is nothing but power actually. So I'll take what I need to do, I need to do power, right? So power is 2 actually. So I square, here it is nothing but a square actually. So what it is internally doing is initially I would be 0, so 0 square would be 0. So I'll add 0 to my L. So in second iteration, I would become 1, 1 square would be 1, 1 will be appended to the list. So after this execution, what my list will look like is, it will look like 1, 0, 1, 4, 2 square is 4, 3 square is 9, and so on actually. So this is how, this is what exactly happening in that for loop actually. Hope this answers your question. Is that clear? So x here, instead of 5, we are having x. So initially x value would be 0. Here what we are doing is we are doing square. And then we are appending that 0, 1, 2, 1, 4, 9 to the list actually. So this is, I mean, we have to initialize and then we have to iterate this entire stuff, right? So we have a shortened notation, which is called list comprehension. What we are doing in this list comprehension is, this is a syntax. This syntax will uh, help us to shorten this stuff actually. So what we generally write is here I'm writing the for loop. So for loop ranges from 0 to 9, right? So if range is 10, it will iterate till 9. So what I'm doing here is I'm squaring. This is the operation that we need to perform on the each element. So initially I'll get 0, so 0 square is 0, and that will be added in the list actually. So the entire this operation is done in single line of code actually. This is the benefit of writing list comprehension. Hope this is clear, right?
So append is changing the list. It's not adding. Changing the structure of the, I mean, changing the type of the list, not adding anything.
No, what is your question? So I didn't get your question.
See, when you say append, you are not adding anything to the list, right?
No, we are adding.
You are
See
changing.
here. See, here list is empty, right? So I didn't have any element in the list here. So
Oh,
here
okay,
what I am doing,
okay.
what do you meant by append is I'm adding 0 to my list. And then in the second iteration, I'm adding 1 to the list.
Okay,
In third,
initially it's empty. Okay, that's fine. Yeah.
yeah, it is empty. And then we are adding the elements actually. So hope this list comprehension is clear to you guys. And then now let's talk about list comprehension with few function calls. So I'm having a list of words. Here, list of words is uh, hello, world, Python, list, and comprehension. These are the 5 words that my list is having. In length, what I'm doing is I am iterating through this list, and then I'm finding the length of each element. So let me share my screen once again. So what I'm doing here is I'm having a list which is called words list. In words list, I'm having a few words. So one word is Python. Second word is machine learning. Third one is deep learning. Something. I have all the words in my list actually. So what my task is, I need to find the length of each word which is present in this list actually. So to find that, what I need to do is I can use list comprehension and then I can do this. So how can I do that? So I'll this is a list comprehension syntax. So I'll have this, and then as this list is having elements, so I will write for loop. So for word in words. So words is my list actually. So in words, what is my first W? My first W is Python. So see here we are getting initially I'm getting Python. Next I'm getting machine learning. Next I'm getting deep learning, and so on. So after getting each word, what I need to do, I need to find the length. So I can use length function. Length function will determine the number of characters are there in that string actually. So number of characters in Python is 6. So I'll get 6 into my first element in the list after iterating after completing this list comprehension. My second would be machine learning. I'll get my length to be 12 and so on actually. So this is how we can use list comprehension and then find the length of each word which is present in the list. So here, hello length is 5. So I'm getting 5 as my output. And then word length is 5. I'll get 5 and so on actually. So here I'm using list comprehension and then I'm finding the length of each word. And then we do have nested list here. The nested list is 1, 2, 3, 4, and 5, 6. So list inside a list is called nested list. What I want to do is I want to flatten the entire nested list actually. So flattening is nothing but I want to get the elements in the list and then append to my list actually. So after flattening, this is what my output should look like. My output should look like 1, 2, 3, 4, 5, 6. Okay, so this is what my output should look like after doing the flattening stuff. So for this, what I can do is I can write the list comprehension and then I can do that stuff. So let me share my screen once again. So here I am having list of list. So this is my nested list. Let's assume this is my nested list. I'll write this as outer. Okay, I'll name this list as outer. So outer of 0, what is outer of 0? Outer of 0 is a list which is 1, 2. What is outer of 3, 4? Outer of 1, which is 3, 4. What is outer of 0 of 0? What is outer of 0 of 0? Which is 1.
1.
What is outer of 0 of 1? Which is 2. So by this way, I can get I can get the values and then I can do that, right? So let me write list comprehension here. So I'm writing list comprehension here. See, now what I am doing is I'm writing for loop. So uh, for list in outer. So if I write this statement, what is my list value in first go? If my outer is this, if my outer list is this, what is the list value in first iteration?
2.
2, right?
1, 2. This is the stuff, right? So in my first iteration, list value is 1, 2. In my second iteration, what is the list value?
3.
3,
3,
4.
4.
3, 4. That is list, right? So with this, we are getting a list. So if I want to go inside that, how can I do? How can I do that? Is I'll write one more for loop. Let's name this as I'll write it as some variable. Let me write it as W in whatever the thing that we are getting. So let's name it as nested or something like that. So here, what is my W value in my first iteration? So if in my first iteration, if I am getting 1, 2, so what this will be doing is this is we will be getting 1. I mean, this is taking the input as 1, 2 actually. This nest can be 1 comma 2, and here we are getting the inner value, inner list value actually. So this first iteration value would be 1 and the second iteration value would be 2, and everything will be stored in this list actually. So this is how, if you write 2 for loops, we will be getting values that are present inside the list actually, list inside the list. So this is what I written here. So what I did is, so for item in sublist, so sublist is my, sorry, uh, so nested is my list. So what I am doing is I am, whatever the nested list that I am having, 1, 2, 3, 4, and 5, 6. I write here reverse actually in my example, but yeah. So here, what we are getting in the nested is, in my sublist, what I'm getting, I'll get 1, 2. In my first iteration, in my second iteration, I'll get 3, 4. In third iteration, I'll get 5, 6. And see, in sublist, in my first iteration, I'll get 1, 2. So for item in sublist is after the entire iteration, the item value will become 1 actually. That 1 will be added to the list comprehension. So once again, I'll explain this. So what I am doing here is, so I'm having 1, 2, and 3, 4. This is my list. Inside list, let's assume this as sublist. Okay. Sublist of 0. Let's say if this name is sublist. So this is sublist of 0 and this is sublist of 1. So let's forget about all this stuff. I mean, let's forget about the list comprehension. How do you plainly do that? Without list comprehension, how can we do that? For a list in, let's assume this to be nested. How can we do that? Nested. What is the list value? A list value initially would be 1, 2. So for, I want to iterate this list actually. So inside this, what I will do is, for I in list, what I will do is I'll create a list here. I'll create a flat. Flat is my list. I'll add that element, whatever the element that I am having, I'll add that to my empty list actually. So this is how we generally do without having list comprehension. Without having list comprehension, how am I doing? Initially, I am declaring a empty list, which is called flat, and with 2 for loops. What my initial for loop will do is, the initial for loop will iterate to all the sublist. And what this inside for loop will do, the inside for loop, will traverse to the sublist actually. So here list value is 1, 2. So what we are doing is, I value in my first iteration, in my first inner loop iteration would be 1, and then the second value, in the second iteration, I would be getting 2 actually. So this is how we can solve this problem without using list comprehension. But with list comprehension, what we can do is we can simply write my first statement, second statement. I mean, first statement, and then second statement, and then I can have item. Item is the ultimate element that we need to add into this list actually. So this is a simple way, without writing that complex structure. This will help us to write in one line actually. Hope this is clear.
Performance both are same, right?
Yes. Good question. Yeah, both were same. I mean, we'll talk about the performance right now. I'm talking about that in the next topic actually. So yeah, let's talk about performance, as Ram has also mentioned. we'll talk about performance in terms of processing, in terms of storing actually. See, list is one data structure which consumes more energy actually, which consumes more memory whenever you are processing large data sets. Uh, let's assume that I'm just creating a small list with 20 elements. So see here, I just wrote one for loop to just print what exactly the size that list is taking. See, to create a a list of 20 elements, it is taking around 250 bytes actually. So let's say if I want to create a list with 100K or 200K or 1 million, so I mean, we need more and more bytes, right? So so let's say if I want to load data from the database, or in real world, we will be having millions and millions of records. So whenever we are loading that data, millions and millions of records from database, we need to store somewhere, right? Let's say if I use a list to store that millions and millions of records, that would be painful because as list is consuming more and more and more memory, that doesn't serve our purpose. So instead of list, what we can do is there is one concept called generators. Generators, what it does is it does lazy loading actually. So generators is a concept that we will discuss, which is an important concept whenever we are dealing with large and large amount of data. So if we have millions and millions of records in our database, if I want, whenever I'm loading that to my application to perform some operation, I might not do that because as this is consuming more energy, uh, we that is not the viable solution to do that. That is the reason why what we can do at this moment of time is uh, we can use something called generator. And then there is one more problem. Let's say we have 1 million records in list, and then I want to remove the element from the list. Actually, there is one user who is not actively using our application, and then the user detail, let's assume that user's information is in that list. It is in the end of the list actually. So if I want to remove that end list, I mean, if I want to remove that user's information, if it is present in the end of the list, then the time taken to remove that is I need to traverse n elements in the list first, and then I need to remove that in the end actually. So the time taking there is order of n. Why it is order of n is uh, let's assume I have a list of information. This is user's information. This is user one. This is user two. This is user three, and so on. I'm having until user 100K. Let's say there are 100K users. I want to delete this 100K users information. So if I want to delete that 100K user information, what would be the time here? So I need to traverse till that point. Let's say if it is having n customers, then my time would be order of n because I am traversing each and every element that is present in the list, and then I'm going till the end. So my time complexity to remove a specific element, which is in the end, or which is in the, I mean, which is in the beginning. So the time would be order of n actually. So here, storage wise, it is taking more time. Similarly, if I want to remove something using pop method, that is also taking order of n time actually. And then See, I do have one problem here. See, what I'm having is I'm having some logs here. Let's assume you have to process 1 TB of your server logs. We generally use server logs, right? In every application, we will be having logs. Let's assume that that file size is 1 TB, and then in that server logs file, what you need to do is you need to find the 5 topmost IP addresses that who are using actually. So to find that, what I did is I have created something called logs. Logs is the uh, logs is the list that it is having the list of IP addresses. So what I did is I I have created around 10 to the power of 6, which is nearly a million records actually. There are million records in my list actually. So here what I'm doing is to find to find the most frequent thing. Here I'm using some concept called dictionary, where I'll talk about this dictionary and then I'll talk about lambda functions in the future classes. But let's not focus on the code much. Uh, it takes more time actually. So what I mean is, let's say if I want to get this information, uh, get the topmost 5 frequent IP addresses, that will take more time. Instead of this, we can use queues actually. So uh, instead of storing a bunch of stuff at once, we might use generators. Instead of list, we can use generators. And then let's say if I want to perform some operations like sort or something like that, instead of list, we can also use alternatively we can use heap queues actually. So there are few drawbacks with this list actually. Uh, as I mentioned, let's say if I want to pop the elements, it is also taking order of n time. If I want to pop some element or remove some elements in the list, it is taking order of n. And then with respect to storage, also it is taking more storage. And then let's say if I want to sort something, it is also taking more time. Instead of that, we can use other alternative data structures that we have in our table actually. So, with that being said, this is a complete overview of what exactly list is, how do we add elements, how do we update elements, and then how can we perform list comprehension and all this stuff. So, if you have any questions, you can ask, or else I'll continue with tuples.
Can you explain the program, that one which you had before? Yeah, this one.
This one?
Yeah.
I will explain, but it would be more sense if if you have an idea of what exactly dictionary is. Here, I want to show exactly what are the problems. That's it. I don't want you. If you know dictionaries, I can help you with that. But if you
Yeah,
don't know
I know
dictionaries,
dictionaries. Yeah.
Can I ask a question too?
okay.
So the example you showed before, like a sublist in a sublist and printing that, what you showed the program, but what you're saying is that's not a good idea to use list, right?
This one?
Right, yeah. This kind of data management is not good, you are saying.
Yeah, let's say if you're having, TBs and TBs of data, if you want to store that entire TBs of data into a list, at that moment of time, it is not good to do that.
Okay, so the nested with subsets is not the best way to store. Okay.
Yeah.
Got it.
Okay.
This item for sublist is a reserved keywords or something like that for
No,
Python?
you
Or
can you can have anything instead of sublist. You can instead of nested. You can have any other name actually. You can play with that. You can have A, B, C, num. But if it is sublist and if it is list, it makes more sense actually. It is just a naming convention.
That's what like. See, 1, 2, we are having one list, and then 3, 4 in one list, 5, 6 in one list. And to flatten it, you're saying like item for sublist because we are treating them as a sublist, each of them, right?
Yeah, I mean it's just naming convention. Instead of sublist, you can write sub one or anything. You can write anything. So I mean
So how
I
do
mean
we come up with this sentence? I mean, how to form this? So that's what I'm trying to understand. If you want to extract something, or if you want to merge this, this is nothing but merging the list, right? We are merging all of
merging
them and
all the
writing
list. Yeah.
and writing. So I don't know what kind of reserved words or keywords or language we should use in this flat function. That's what I'm trying to understand. Okay.
See, that is what I'm saying. So let's assume that you don't have this list comprehension. Without this list comprehension, also we can do that. As I have shared you the screen, and then as I have explained you with two for loops, you can do this similar task actually. So whenever you are iterating something, it is just a naming convention to have that names actually. So just I'll share my screen once again.
Yeah, that's fine. That's fine. So yeah, it's
So
okay.
here,
That's
what
okay.
I'm doing is, so
We'll look
my
for next.
outer. Okay, okay. So yeah, I mean, we don't have. They are not the predefined functions. Actually, they are not predefined terminology. Here, we can have any name. Actually, it's not a naming convention that we have to use the sublist or nested. The thing is that you can use any name here. Any other questions?
Can you just go up a little bit to the pop?
Pardon?
Yeah, here.
Uh-huh.
So we have these logs and up a little bit up pops. There was something called pop on the top.
Okay, okay. Uh-huh, uh-huh.
Measure pop from the end.
What generally a pop will do is if I use pop, let's say if my list is having let's say 1 million or 1 million records, what it will does is it will directly go through the last element, and then it will pop the last element. The time taken by pop method to pop the 1 millionth record is order of one. Let's say by using pop method, let's say if I want to remove the first element, then it might take order of n, because from last it has to traverse n number of elements to remove that first element actually. So at that moment of time, we need order of n time instead of order of one actually. So in this case, instead of, let's say if removing is my concern, let's say if my data, I'm having queues data, and then if I want to remove at this moment of time, what I can do is I can use other data structures like DQ or something like that. So these are what my main intention here is, to show you guys that lists are having some problems. Let's say if with respect to storage, or let's say if I'm removing something, or let's say if I am also sorting something, there we might be having some issues, and then these issues can be solved with other data structures. That is what I'm going to show you guys here.
So if you want delete or remove any middle element or nth
That
element
that
of a
also takes order of n, right? I mean, it depends. So let's say if I want to, if I can delete any of the middle element, or I can delete, any element. It depends on the size of the list, right? So the time complexity would be order of n. In worst case, we might need to traverse the n elements, right? At that moment of time, the time complexity would be order of n.
Okay, thank you.
Probably
Whenever we
we'll
are,
understand this when we apply this in one of
yeah,
our practical system, that maybe.
yeah.
So,
So let's talk about tuples now. Similar, like list. Tuple is also the collection of elements, ordered collection of elements. Similar to list, we will have tuples actually. Tuples will, every element in the tuple will have an index. That is the first thing. So it is called. That is the reason why it is called ordered collection. So, and then the main property of tuple is immutable. So lists are mutable in nature, whereas tuples are immutable in nature. What is immutability? Mutability is nothing but you can change the elements, you can update the elements. Let's say after creating creating tuple, you can't change the elements in the tuple, or you cannot add the elements, or you can't delete the elements in the tuple actually. So tuples are immutable in nature. Let's say if I want to create an empty tuple, how can I do that? Is lists are we can denote a list using square brackets. Similarly, tuple can be uh, created using uh, parentheses actually. So these are the uh, brackets where we can this is how we can create an empty tuple, and then I can also find the tuple type of the tuple by using type function that I have mentioned yesterday. So you can have type, and then you can have an empty tuple as an parameter to the type function, and then type function will say the variable that you are passing, it is saying that the variable is of type tuple. And then here I'm creating a tuple with 1, 2, 3, 4, 5, and 6. So these are the values that I'm passing to tuple. And then, see, this is the list. To convert this list into tuple, we will use a function called tuple. Tuple is a function which can be, if I write 1, 2, 3, 4, 5, yeah, here I'm passing list. I'm converting the list into tuple using tuple function actually. Yesterday also we have seen int of, let's say if I pass a string value to the int function, what it is doing is it is converting string into integer. Similarly, here I'm converting a list into tuple actually. And then how can I access the elements in the tuple? It is similar to the list. I'm having forward indexing and backward indexing. Uh, Let me share my screen. Yeah, I'm having forward indexing, backward indexing, the same stuff as a list actually. So let me assume this as a tuple. This is tuple T. And then in my tuple, I'm having 1, 2, 3, 4, 5, 6. So let's assume these are the elements are as 10, 20, 30, 40, 50, 60. These are the elements that are present in the tuple. So I'll have forward indexing, and then I'll have backward indexing. So in forward indexing, this is how uh, the indexing has been done. If it is in reverse or negative indexing, we will have -1, -2, -3, -4, -1, -6. So if I want to access 60, I can access using T of 5 or T of -1. And then as I also said you few examples for slicing. Let's say if I want to access the elements in bundle, how can I do that? Tuple name, I'll have start index, I'll have end index, and then I'll have a step count. So my start index, I want to start from 0, and then I want to start from 0. So 1 minute, guys. I want to start from 0, so here I'll have 0, and then I need to go till 3. So if I want to go till 3, I'll have fourth element, 4 as my n index, so that it will traverse until n-1. And my step count would be here 1. If I want an alternate number, I'll have step count as 2. So this is how we can we can do slicing in the tuple actually. So this is how I can access the element in the tuple. This is how I can also do the slicing. Here we will not be having much operations for tuple, because if you can change any of the element in the tuple, we will get an error, because tuple is having one unique property, that is immutability. So if you change any element, let me do that here. So I will define a tuple with 10, 20, 30, 40. So what I will do here is I want to access first index element. So it would be 20. Now what I want to do is I want to change the value of T of 1 to 80. Here I can't do that because tuple doesn't support any item assignment, or we can't change the values in the tuple actually. Let's say if you do this same thing for list, you will you'll update the value from 20 to 80, but
But
as tuple is
how does
immutable.
it identify tuple? You didn't say tuple here, just
Yeah,
T, right?
yeah. See here, if something is enclosed in square brackets,
Oh,
that is
parenthesis.
denoted as, yeah. Yeah, if it is parenthesis, it is tuple actually. So that is the reason why it is recognizing that. So yeah, you can't, as I said, as this tuple is immutable, we can't modify all this stuff, and then so operations would be minimal. So we can't add the elements, we can't delete the elements, so we can't update the values in the tuple. So operations would be less. See here, what I am doing is I'm having a tuple with a mixed name, with mixed underscore tuple with 7, 8, and in numbers, what I am storing is I'm storing 1, 2, 3, 4, 5, 6. What I am doing is I am doing the concatenation. So what this does is that whatever the elements that are present in one tuple, uh, what are the elements in the second tuple, we are just making them into one tuple actually. So this is just the concatenation of two tuples. If I Here what I am doing is I am creating new tuple, and then I'm adding the elements of both the tuple. If I try to assign it to any of the old tuple, then I'll get an error. Why I'm getting an error is because we can't change the tuple by nature. If I try to assign for numbers, or uh, just give me 1 minute. Just saying numbers is not defined. So here, let's say if I add the two tuples, one tuple is having 1, 2, 3, 4, 5, 6, and then second tuple it is having 7 and 8. Let's say if I add these two, what's happening is why numbers is having 7 till 8. Just give me a moment. Once again, I'll add numbers. Yeah. But I mean, I think here this is happening. Let me share my screen once again and help you guys with this. So here, what's happening is here I have a tuple. Uh, not sure why it is. Just give me a moment, guys. I'll try. Okay, that's not working, but yeah, it's not a problem. So what's happening is here, the whatever the numbers that the old tuple that we are having, the object of that old tuple is being, I mean, it is being replaced actually. The old tuple is being deleted, and then we are only having new tuple here, new tuple with after the concatenation. That is what happening here. That is what I mean to say, but it would be great if I have some pictorial representation. Let me try here. Okay, yeah. So here I'm having one tuple. The tuple name is T1. Uh, l- the tuple name is number. So in that tuple, I'm having some numbers. I mean, in that tuple, I'm having some values. So, and I'm also having another tuple, which is mixed underscore tuple. So in this mixer underscore tuple, I'm having some values. So now let's if I do concatenation, and then say if I do concatenation, I'll get all the values. I'll get all the values in this tuple, and then what I am doing is I am I'm what I'm doing is see I'm assigning that to num. So what happens here is that the old object, the old tuple objects, whatever we are having, that will be deleted, and then with the number a new tuple will be created, and then the values in the new tuple will be added to that whatever the new values that we are having, that will be added to that num actually. See, the if you we can't in any sense we can't change the values in the tuple, but let's say if I do any assignment like this, so what happened is that the old object will be deleted, and then whatever the new instance, whatever the new values, new tuple that we are having, that will be assigned to new object actually. So this will be deleted, and then num will be given to new tuple. This is happening. This is what exactly happening here. And the similar thing happens when we do the multiplication actually. So here what I'm doing is whatever the multiple mixed underscore tuple 7 8, here I'm multiplying thrice, which means that 7 8 7 8 7 8, all these elements will be formed into a new tuple. I can assign this to mixed underscore tuple, but what happens is the old mixed underscore tuple will be deleted, and then the new values will be assigned to the new object actually. Hope this is clear for you guys.
Yeah, please go ahead.
Okay. Yeah, and then if I want to find the count, how can I do that is I can have a method called count. Count will give us how many times that value is present in the tuple. Let's say if this is my tuple, what is the count of one? As it is having only ones, I'll have one as my output. Let's say if value is repeated, it will give us the count actually, and then index. So what is the index of 3? To find the index, we will use index method, and that index method will return us the index of that particular element. Similarly, just like nested list, we have something called nested tuples. What this nested tuples, what we are doing here is here we are having tuple of tuples. So if I want to access the first element, how can I do that is nested tuple of 0. Nested tuple of 0 will give us a tuple with 1, 2, 3 as an output. What is a nested tuple of 1 of 2? So nested tuple of 1 is this, of 2 is 0, 1, 2, which is C. So that is the reason why we are getting C as an output. So this is how nested tuple look like. And then let's say if I want to iterate through nested tuples, how can I do that is by using for loop, nested for loops, we can do that. So in first for loop, what we are doing is we are getting subtuples actually. So in the first tuple, what we are having 1, 2, 3. Item in subtuple would be 1. In first iteration, I would be having 1. In second iteration, I will be having 2. And third iteration, I will be having 3. This is very similar to nested if actually. So I want to explain this scenario, guys. So here I'm taking you to one scenario. See, what is the scenario is I have a load balancer in a distributed system. What we are doing is we are building a load balancer for distributed systems with the multiple server process that comes the incoming request. Let's say if I'm having a distributed system, and then in that distributed system is what I'm having a load balancer. Now, what in that load balancer, I do have multiple servers. What I want to do is now this load balancer has to decide. Let's say if I'm having 100 requests, if one server is handling 100 requests, second server is handling 5 requests, and let's say if third server is handling 7 requests, as the second server is doing less work, I want to assign any new coming request to the server B actually, because server B is serving less request. So here, what I want to do is I want to distribute the request equally across all the servers based on their load, based on how they are serving the request. I want to keep track of the server state actually. I mean, each server state would contain generally IP address, server health, and then I need to have something called current load. I mean, how many requests the server is serving. And then I need to ensure data consistency with multiple reads actually. As we are doing multiple reads and updates, I need to maintain the accurate server information. What I need to do is I need to implement this entire stuff using list and tuple. Okay, this is the main goal. I want to, implement something actually. That is the reason why I took this scenario. So, this is how I'm storing my server information. So, see what exactly the server information is. So, servers is the list of tuples. Here I'm using list of tuples. So each tuple is having the information of the server actually. So let's say this is the IP address of server 1, and then what port, and then I'm also having the current load. So this is the list of tuples. What I want to do is here, let's say if I get any new request, I want to check what is the which is a server that is having some capacity to serve that request. To do that, what I am doing here is uh, I'm writing a function. What this function will do is that this function will return me which is the server that is handling the less request actually, which is having some capacity. To do that, what I am doing is I'm using here minimum function. What minimum function will do is that minimum function will find the minimum in the list or any other any other dictionary that we are using. So here, what I am doing is, let me explain this to you guys. So here, what is servers? Servers is it is list of tuples actually. So for each tuple, what we are doing is what I am doing is here I'm writing a lambda function. So yeah, what lambda function is, so what exactly function? A function, as I said in yesterday's class, a function is a set of statements which is used to perform a task actually. So let's say I'm having a function which is performing a simple task, like uh, let's say if this function is finding the smallest element in the list, or let's say to find the largest element in the list, we can write functions actually. But there is some concept called lambda and anonymous functions. What these anonymous functions is, they are just like a shortcut actually. They are the shorthand notation. They are shorthand notation of the functions actually. Similarly, see, we have seen list comprehension concept, right? What list comprehension is doing, it is the shorthand notation of something big, right? We do have some for loop. Let's say if I want to do squares, I need to declare a list, and then I need to write all this stuff. Similarly, in functions, if I want to do a small operation, if I want to do a small operation, it would be, we need to follow all the syntaxes. Without that syntaxes, this lambda function will help us to write in one or two lines actually. Yeah, tomorrow's or day after tomorrow class, we'll talk about functions and lambda functions in detail. But as we need this, that is the reason why I'm explaining why we need lambda functions. What we are doing here is, uh, here we are taking the entire, we are taking the entire servers, and then what this lambda function here we are doing is, we are just grabbing the 10, 20, and 50 from these tuples actually. From these tuples, what I am doing is, because I need to check the current load, right? Based on this current load, let's say if I get some incoming request, if server 3 is having less capacity, if it is having less load, I need to assign this new request to the server actually. To do that, first what I need to do, I need to find what is the server that is having less load. For that, this is the logic. Here, what I am doing is, I'm using minimum function. In this min function, what I am doing here is, I am passing my list of tuples here, and for each value in the tuple, what I want to do is, I want to perform some operation. What is the operation that I need to perform? I need to perform. I need to take the value, whatever the value that current load is having. I need to get that value, and I need to check what is the minimum current load present, in the entire servers list actually. Let's say if my third server is having the small current load value, whatever the new request that I have, I need to assign that new request to that. So with this function, you'll get to know about this entire stuff whenever I'm talking about anonymous functions in more detail actually, where we have some functions like reduce and all this stuff actually. So yeah, you'll get more in detail of all these lines. But what this function as a whole is doing is finding the minimum current load server actually, in the entire in the server list actually, in the server list of tuples. So see here, here what we are passing is, we are passing servers list to the
So
this function, and
here,
then. Mhm.
key is called lambda x colon x of to means
Yeah,
what
this
it
is
is
a
exactly?
syntax. Yeah, it is a syntax. What this lambda function generally does is that whatever the input that let's take this as the x. See, in my first iteration, this is my x, right? So this is x, and then in this x, what is x of 2? X of 2 is 10, right? So x is a parameter actually. So a parameter to the function. uh, so yeah, I mean, so let me explain you. If you want, I can explain the lambda function. But what we are writing is without any function names. This lambda function, we'll just have the parameter. The parameter here in our case, the parameter is one tuple actually. So we are passing one tuple, and then we are getting the third value. We can write this without lambda functions also. Uh, Simply what here we are doing is we are just getting uh, the whatever the third value in the tuple, and then
Okay, so
we are
third value is
finding the
nothing
new.
but the load or what is this?
Yeah, it is current load.
Okay,
We're
fine,
just
got it. Okay.
getting the current, we are just extracting the current load, and then we are finding the minimum, whatever the minimum value that we are having. That is what this entire function is doing. We can
Okay,
write
fine.
this without lambda functions also.
Okay, so
Yeah,
this is server IP and then port and then load, right?
yeah, current load.
Okay, got it. Okay, fine. So it just sorting based on the which has the lower load. Okay.
Yeah, low load, and then the incoming request, whatever the incoming request is, uh, we need to give that new request to the low. I mean, whatever the wherever the load is less. So for that, what this function is doing is what we are doing here is uh, we are finding the less load server, and the third step comes is to update the server load. Uh, I mean, as let's assume that the server 3 is having some capacity, and then and server 3 is is having less load. So in that case, what we will do is we will give that new request to that server, right? So in this case, we need to update the value of let's say if we assign new request to server 3, we need to update the value of that current load, right? Because it is serving new request. So as we can't see here we are storing the information of IP address, port, and current load in tuple. We can't change the tuple, right? As tuples are immutable in nature, we can't change the tuple. So in this case, what we can do is we can use something called a dictionary. Dictionary is a data structure which will help us to uh, what that data structure will do is we can store the information in key value pair actually. So here, what I am doing is I am creating a dictionary. So here in this dictionary, what I'm having is I'm having a key and then a value. So every dictionary, list, it is just ordered collection of elements. Similarly, tuple is also ordered collection of elements. But dictionary is a data structure that stores data in the form of key value pair actually. So here I am having a key. What is my key? My key would consist of IP address and then the port. Value here is uh, value here is the load actually, current load. So if I create a dictionary like this, what I can do is I can change, let's say if there is any new request, what I can do is I can I can change the values in the dictionary actually. So this will help us, let's say if I convert uh, my list of tuples to dictionary, what it will help is here it will help us to change the values actually. Here we can, let's say if there is any new request, we can change the value from 5 to 10, or you can update anything. So one cool feature of dictionary is all the keys, whatever the keys that we are having, keys are immutable, whereas values are mutable actually. So what I mean by this is in key value pair, if you declare a dictionary, only only values are, we can change the values, keys can't be modified. So as the IP addresses and the port numbers are fixed, so what we can do is we can add them as a key value to our dictionary, uh, and then I can add the load uh, as a value, so that whatever the load is, we can change the load. Let's say if we have new request, I'll add some value to current load. Let's say if that service, if that request is already processed, we can decrease that also, right? So to update something, as we can't change the tuple, what I am doing is I'm converting that tuple into dictionary actually. So this is called dixt comprehension. I'll talk about this in detail, but what I want to show here is that where to use list and where to use tuple actually. So here, let's say if we have some information which is not changed in future, here it can be IP address or it can be user information or some information like SSN, or if there is some information which can't be modified at that moment of time, what we can do is we can use tuples, and then we can store that information in tuple so that no one can modify that information. And then we can also use the list wherever we want. If we want to store some information in ordered collection, uh, if you want some indexing on all this stuff, we can use list actually. So this is a very small scenario where we have used.
See, whatever you stored in the dictionary, the same thing can be stored in the tuple as well as list
Yeah, we
also,
can
right? So what
see.
is
Yeah.
the difference?
See, but yeah, the thing is, if I want to, I can't change if I declare this information in tuple, I can't change the tuple, right? I can't change the 10 value here. Let's say after serving some request, I can't change this, right?
Yeah, list you can
So
change, and dictionary you can change, or you cannot
yeah,
change.
dictionary. Yeah, see here, the best thing is dictionary. That is the reason dictionary. As I said, we can only change the value, but not key. Actually, we can't. We can change the value. As I said, it is key value pair. We can change key. We can change value, but not key. Okay, so here it is a classic example where if you don't want to change some information, we can store that information in tuple actually. So here IP address can't be modified. Similarly, port. That is the reason why we are storing that information in tuple. This is an application where, in many of the scenarios in real world also, if you don't want to change the information, if there is some fixed information like latitude, longitude, SSN number, Aadhaar details, PAN details, IP addresses, in that scenarios we will use tuple where that information is not modified more often. And then I have one more scenario. In this scenario, what we are having is it is an e-commerce order details. So what we want to do in this application is we want to manage the queue of customer order efficiently. We want to process that actually based on, let's say, so each and every order is having all the details like what is the status of that order, and then uh, if the status is pending, we need to take that order actually, and then we need to process that order. If the order is shipped, uh, we have to remove that entire customer information from our list actually. And then let's say if someone cancels our order, what I need to do is I need to remove that from my orders list actually. So see here, this is my order list. What order list is having is customer information like order ID, name of the customer, priority, and then status of the order, and then what are the items that the user has ordered. So this is the order information. What I want to do is here I'm writing a function. What I am doing here is processing uh, I'm processing all the orders actually. If there is any priority order, let's say that the priority is mentioned in third index of every list actually. What it does is, if it is normal, we will process on first come first serve basis. If it is urgent, we want to process that first, and then we need to process the next items actually. So what this process order is doing is, if I don't have any orders, we will simply say nothing. As we don't have any orders in the orders list, we can say no orders to process. If not, if we have some orders, what we are doing is, first we are checking whether our if we are having any urgent orders or not. If we are having urgent orders, what I am doing is I'm adding that to my urgent list, and then I'll process that urgent list first actually. So to do that, what I'm doing is, here I'm creating a list comprehension. What this list comprehension will do is, in this, whatever the list that I'm having, I'll check. See here, I'm checking whether order of two is urgent or not. If it is urgent, I'll take this entire I'll take this entire order, and then I'll store that in urgent underscore orders actually. If I'm having urgent underscore orders, I'll process that first. If not, I'll process based on first come first serve basis actually. So what do I meant by processing is, it is nothing but changing the status from, I'll change this pending status from pending to processing actually. I'll update this value. That's it. I'm not performing any complex thing here, but I'm just I'm performing manipulations on the list actually. Here we are using list comprehension, and then we are storing the urgent orders. Let's say if we are having urgent orders, what I am doing is I am processing that urgent orders. If not, I'll take uh, I'll take orders from the on first come first serve basis actually, and then I'll update that process. Finally, after processing all that stuff, I'll change that whatever the information, that if it is pending, if it is already processed, I'll change that information to processed. Yeah, this is what we are doing. This is just a processing logic. Yeah, once after doing process, let's say after processing, what we will do is we will change the status of, after processing, we'll change that status to be shipped actually. Let's say if the orders information is under processing, what we will say is that we will change the status of uh, pending to shipped actually. And see, once after the order is shipped, I will remove uh, that orders information which is in the orders list, and then if user also cancels the order, I'll remove that order from my orders list actually. So these are the four basic operations on list. What I am doing is I'm finding uh, priority items based on one of the element. Here the element is normal and urgent. So here, based on this element, I am finding the urgent orders, and I'm changing the let's say if item is processed, I'm changing the status from pending to processed. and then let's say if item once after it is processed, what I'll do is I'll mark it as shipped, and then I'll ship the item. Once after shipping that, I'll remove the item from the orders list, or if user cancels that, I'll remove this order actually. So in this way, we can perform operations on the list actually. So if you have any questions in these two scenarios, you can ask now. What my main intention here is to demonstrate how and where this list and tuples are used.
What are the status actually? Urgent and pending. So urgent is what and pending is what? Both are put together, right?
No. I mean, a normal and urgent is a priority. So let priority in the sense someone will order from Amazon. If you are a Prime customer, you'll be having some priority, right? So that is what priority is all about. Here, pending is the status actually. So uh, whether the item is if it is pending, the item is not picked yet. Actually, the store haven't picked that order. Processing in the sense they are packing all this stuff. Actually, shipped is an
Yeah, got
ultimate
it.
end goal.
I didn't see that. I got it.
Okay.
Yeah.
Okay. Anything else, guys? If you have any questions, you can